11:32.
Yeah.
Alright, so in this experiment, we're trying to,
Well, first and foremost, the experiment's called the conservation of momentum. That's what the experiment is.
yeah, so we're trying to explain what the conservation of momentum is in this experiment, for which we're gonna measure the time. We have two masses here. This is mass 1, and this one right here is mass 2. And what we're gonna do is, first we're gonna do the inelastic momentum, in which these two areas, we're gonna have one right in the center of the photo gate, so it's gonna measure the initial time, and this is gonna measure the final time, right? And then we're gonna put this mass number 1, mass 1. We're gonna put mass 1 over here, and mass 2 is gonna be right here in the center.
So what you're gonna see is the momentum of mass 1 going through the photo gate, grabbing the time for us, and then attaching to the second one. And you'll see a significant result where the time here will basically be doubled from the first one, because it's adding on to the mass of the second one as well.
Which means that if the time is double, if the final time is double than the initial time, that would mean that as soon as these two masses go through the second photo gate, that means that it will be going slower. Okay?
So this is going to be attempt 1 of many, if you could turn on.
I'm holding it right here in the middle so like it doesn't. Ready?
Where's the first time?
So the first time is 0966.
And the second one?
Is 0.2124.
So pretty much the double.
And yes, indeed.
There's some variables there, but it's initially doubled. of
Yeah,
what
it's
it
roughly
was.
about double the time, which means if you could even tell if you look from the video that as soon as mass 1 make contact with mass 2, they start going much lower
They got
than the initial than the mass number 1.
Good. How about the second experience?
You gotta talk to
So
me.
the second experience is about elasticity. So we're gonna do the exact same experience, but with the springs on each end. And so what we're gonna see is that the time that's this one is gonna go through the gate, and as at the moment it's gonna touch this one's gonna stay at rest, and the other one is gonna go, because they have the same mass, the other one is gonna go at the same time as this one on this gate. You wanna do it?
Let's do it.
Ready?
So the time that I got on the first photo gate is 0664.
And then time on the second one is 0.0695.
So it's super close to being very similar, but we have to take into consideration certain variables that happen. Since we had a spring on this end and a spring on this end, the time of the collision was slightly longer, so that's why that one's just a tiny bit longer than the first initial
So
one.
what's going on here is that as soon as the mass 1 makes contact with the other spring, the weight and the force of mass 1 transfers over to mass number 2. Therefore, the time at which it passes the second photo gate should be the same as the first one.
So when we say the force, we mean the momentum.
Yeah.
So yeah, the momentum of one is transferred to the other one, as long as they have the exact same weight.
Mhm.
If we also did an experience, which we can talk about, is that if we put weight on one end and not on the other hand, then the transfer of the mass, the transfer of the momentum is going to be very different. And if the first one is heavier than the second one is going to go much faster. And if the second one is heavier than the second one is going to be slower.
You will also see that the first one that is heavier will no longer stop where it collides, but it will continue with some momentum as well.
Yeah.
Um,
On
and-
either side, it depends on the.
Yeah, it depends. So if this one was lighter and this one was heavier, you see that this one would actually get pushed back, and this one would basically not move. It'll move, but at a very slow
Slower.
pace. Thank you guys.
Thank you for
Subscribe. Hit that button right there.
Hi guys.